complex number problem, year 2000, A-level question. So first part you have to show algebraically modulus and the argument of the complex number. That is minus 1 plus I whole thing power to the power of cube 1 plus I to the power of 4. This one. What is the easiest way to simplify this? But you have to find the modulus and the argument. If you want to find the modulus and the argument, first you have to simplify this complex number. Thereafter you have to express in polar form. Then you can express the modulus of and the argument of this complex number. Right? So if you simplify this one, minus 1 cube plus 3 minus 1 squared I plus 3 minus 1 I squared plus I cube over, this can be expressed as 1 plus I whole thing squared to the power of 2, right? That is, you can write this one, this actually 1 plus I whole thing to the squared power 1 plus I whole thing to the power of 2 to the power of 2, right? So if you express this 1 plus 2I plus I squared whole thing to the 4, right? This minus 1 minus 3I plus 3I minus 1 squared is plus 1. Here I squared is minus 1, minus into minus 1 is plus 1 plus 3 minus I. But you know that I squared is minus 1. This minus 1, this 1 get cancelled. Right? That is 2I to the power of 2. So this equals 2 plus 2I over 4I squared. So this equals minus half I. Okay. Now you can take half out plus half out, and root 2 also you can take out. 1 over root 2 plus I into minus 1 over root 2. So this equals 1 over root 2 times cos minus 3 pi by 4 plus I sin minus 3 pi by 4. Right. Then what is the modulus? Modulus equals 1 over root 2 argument minus 3 pi by 4. So this is a principal argument, but you can give any argument in this case because they are not specifying whether it is principal argument or not, right? But this is a principal argument. You know, Principal argument is of a complex number always theta. The principal argument is always theta greater than minus pi, less than equals pi, right? So this is the range of principal argument. This is principal argument, range of principal argument. So if you look at the next part of the sum, part B, the point P1, P2 represent the complex numbers C1 and C2 respectively in the Argand diagram. Provide a geometrical construction to obtain the position of the point which represents complex number C1 plus C2 in the Argand diagram, right? For these, for any two complex numbers, so you can take two complex numbers as C1 and C2, right? Let's see how you can do this construction. So you can take let C1 equals x1 plus iy1 and C2 equals x2 plus iy2, right? Then you can construct like this. P1 Z1 P2 Z4. XY. So you have to take Z1 and Z2 be represented by the points P1 and P2 respectively, right, in the Argand diagram. Now how do you do the construction? Construction is very simple to do, right? What is the construction? Complete the parallelogram OP1 QP2 OP1 QP2, then C1 plus C2 is given by point Q, right? Point Q. Then how do you construct parallelogram? So you can construct this parallelogram in unique way. So this is a point Q, right? Like this. You have to construct OP1 QP2 parallelogram. Then C1 plus C2 is represented by the point Q. Okay. Then proof. Let C dash equals x dash plus iy dash be the complex number represented by Q. Then Q equals x dash y dash. The coordinates of the point Q is x dash y dash. If you take a complex number is represented by the point Q is x dash plus iy dash, then coordinates of the point Q is x dash y dash. And what is P1? Coordinates of P1. Because P1 is a complex number represented by P1 is C1, that is x1 plus iy1. Therefore, coordinate of P1 is x1, y1. P2, x2, y2. Now you take the midpoint of this parallelogram, right? So you can take L. As L is midpoint of Q. OQ. So L coordinate is x dash by 2 plus y dash by 2. As L is midpoint of P1, P2. So what is the coordinate of L? x1 plus x2 by 2, y1 plus y2 by 2. So these coordinates by coordinate geometry. Coordinate geometry. P1, L is the midpoint of P1, P2. So if you add two coordinates and divide it by 2, you can have the coordinates of L, midpoint. Then similarly you can divide the coordinates of the origin is 0. This point is x dash y dash. If you two coordinates divided by 2, you get the coordinates of L, right? Then same L you can got in two different ways. Therefore, x dash by 2 equals x1 plus x2 by 2, y dash by 2 equals y1 plus y2 by 2. From this you have x dash equals x1 plus x2, y dash equals y1 plus y2. So what is z dash means now? Now c dash equals, instead of x dash y dash you can substitute. So c dash equals this one, that is x1 plus iy1 plus x2 plus iy2. So this is c1 plus c2. That is how you prove sum of the two complex numbers. Construction. In this construction includes the proof also, right? So you have to provide the proof. Right. So next part. What is next part? Then they have given C1. What is G1? C1 is 1 plus I over 1 minus I. What is G2? Root 2 over 1 minus I. Using above result, find the C1 plus C2. Deduce that tan pi by 8 equals root 2 minus 1. What did you notice about these complex numbers to it? So you can simplify this one. This one half times 1 plus 2i plus I squared. So this equals I. C1 is simplified to I. If you take C1, can be simplified to I. Right? What is C2? Root 2 1 plus I over 1 minus I squared. So what is the conjugate of the bottom? 1 plus I. by this conjugate you multiply top and bottom, then you get root 2 times 1 plus I over 2. I squared is minus 1, minus 1 plus 1, this equals 2. So this equals half plus half pi C2. What is this complex number in polar form? Do you want to express these complex numbers in polar form? Yeah. Better if you express these complex numbers in polar form, right? Because they request for a certain angle. This equals 1 times cos pi by 2 plus I sin pi by 2. This one C2. C2 equals this same as initial complex number. No? What we initially, what is, we got a certain complex number that is also similar to this, no? 1 over root 2 times so this equals 1 over root 2 is this one, no? So this equals G1, G2 equals 1 over root cos pi by 4 plus I sin pi by 4. What are the properties of C1, C2 you notice? Can you notice any properties on this two complex numbers? What are the special properties of these complex numbers, C1 and C2? Do you observe anything? Hello?
Yes, I'm thinking.
What did you observe in these complex numbers? Anything important thing? C1, C2 both equal in magnitude and in moduli, right? Modulus of C1 is 1. Modulus of C2 also 1, right? That means length of complex numbers are equal. Now, arguments also known, right? If you construct sum of these two complex numbers, what is the shape of the object you obtain?
Square.
Square.
Yes, sir.
If it is square, then the difference of angle between two complex numbers should be pi by 2, not pi by 2. Rhombus. So you have to notice those properties. If you notice those properties, very simple this sum. Nothing, very easily you can provide the answer, right? Now you see one complex number is 45 degree, right? Like this. Make 45. This pi by 4. This is C2. C2. C1 is like this.
Because it's not from the C to yes, sir. Yes.
Yeah.
So why isn't it just?
So this is a rhombus. Without noticing those things, this sum is very difficult. You find very difficult. If you notice those properties, you at once you identify that this is a rhombus. Therefore, angle also very easily you can understand, right? O x y like this. So this is P1. So you can take this one P1, this is P2, this is Q. Now what is G1 plus G2? OQ. OQ. C1 plus C2 equals, if you simplify C1 plus C2, what would you get? From this, algebraically you can get C1 plus C2. Algebraically, if you get C1 plus C2, that is 1 over root 2 plus I times 1 plus 1 over root 2. Okay, here also root 2, right? Okay. Algebraically, you just add these two complex numbers. If you simplify algebraically, you get 1 over root 2 plus I times 1 plus 1 over root 2. Is it clear?
Yes, sir. Yes.
Right. Now, what is this angle? What is this angle and this angle? Are they equal or not?
Equal, sir.
Equal, yeah. What is that angle? Pi by? Total angle is pi by 4, then pi by 8. Pi by 8. So you can, if you do a construction like this, if you draw perpendicular to this y-axis, straight away you can calculate tan pi by 8 geometrically, you know. If you mark this point is R, then what is tan pi by 8? Tan pi by 8 equals RQ over OR, no? Right? What is RQ? RQ is x coordinate of this complex number. Right? RQ. This is 1 over root 2. This is 1 over root 2. Coordinates of this point is 1 over root 2 times 1 plus 1 over root 2, no? Because sum of these two complex numbers, this one, that is length, this length is 1 over root 2. Right? This length is 1 plus 1 over root 2. So tan pi by 8 equals 1 over root 2 over 1 plus 1 over root 2. So this equals 1 over root 2 plus 1. So if you, this equals root 2 minus 1. So tan pi by 8 equals root 2 minus 1. Okay. So you multiply top and bottom by conjugate of root 2 plus 1, that is root 2 minus 1. Not the conjugate, you make this rational, right? Make denominator rational, then you get top and bottom multiply by root 2 minus 1. Then bottom you get 2 minus 1. 2 minus 1 is 1. So this equals root 2 minus 1. Okay?
Yes, sir.